Hello guys, this is Prime Concept. In this video, I want to look at the further studies on vectors. I've done a lot on that vector, so this time we'll be concluding vectors by looking at multiplication of three vectors. We have studied multiplication of two vectors where we considered the dot product and we also considered the cross product. So, but this time we want to consider multiplication of three vectors. And in our earlier video, we established that there are two types of multiplication for three vectors. We said number one is called scalar triple product. And then number two, we said is vector triple product. So we want to consider both of them in this video very fast because there's nothing much here. We just want to establish what it is and then take an example. It's very straight to the point. So for scalar triple product, for scalar triple, this would involve the multiplication of three vectors that yields a scalar. That is why you call it scalar, and you call it triple because it involves three vectors. So scalar triple is the multiplication. This is multiplication of three vectors that yields a scalar. So this is actually the triple product, the scalar triple product. How is it done? Say we have three vectors A, B, and C, then their scalar triple product, scalar triple of A, B, and C is going to be A dot B cross C. Let me correct this. So this is going to be A dot B cross C. So this is the scalar triple product, A dot B cross C. And this result is actually the same as C dot A cross B. This is also the same as B dot C cross A. So these three would always give us the same answer. But the moment you mix it differently from this, your answer will no longer be the same. How did I actually achieve or remember this result? What I've just done is, if I know this first one, for me to get the second equivalent, I'll just take C to the back. So that I'll have C at the back, then A and B. That's what you have here. So if I have this, I'll take B to the back, I'll then have B at the back, then C and A. That's what I've done. So these three results would always be the same. But if you mix it, say you now write A dot C cross B, this will no longer be the same. This will be negative. So take note of the three equivalent results I've given you. And at the end, if you understand this is triple. It mustn't always be with the alphabets A, B, and C, right? Now, I'll give you, if you already understand this combination, say we have D dot E cross F. Give me the other three equivalents for this. Drop the answer to this in the comment section. How else can you combine these two that will still have the same result as this, just like I combined this? So the alphabets mustn't be the same. So this is what we call scalar triple product. And how do we solve it? It's very simple. One of the ways we can solve problems like this is to first find B cross C. When you find B cross C, then you now use that answer to dot with A, right? But that is very long. An easy way to solve this is to actually use the determinant method. So what it means is that A dot B cross C, we can use determinants to solve this. I would simply arrange the components of A, which is going to be AX, AY, and then AZ. Components of B, BX, BY, and BZ. Then components of C, CX, CY, CZ. So this is how we solve it. Once you get the determinant, it will give you the correct answer. So I'll take a quick example that will help us digest and understand this. Now let's say let's say we have A equals 2I minus J, B equals I plus K, C equals, let's say, J minus 2K. And let's say we have this question says find A dot B cross C, then find C dot A cross B. So we're going to use this to confirm if this result would be true, would be the same. So very quickly, I already mentioned that we can use the determinant to solve it. So A dot B cross C, using my determinant, I'm going to have, I will arrange the components of A first. Now this, the coefficient of I is 2, coefficient of J is minus 1, and the coefficient of K, there's no K here, means I'll put 0. Then I'm done with A. So I'll quickly move to B. The I component is 1. There's no J here, so I'll put 0. The K is 1 also. I'll move to C. For C, there's no I, so I'll put 0. The J, I have 1. And the K, I have minus 2. So this is what I have. I'll find this determinant. So I want to teach you another way for solving determinant of a matrix. So I hope you would value it, or you would like it, or you would prefer it. But let me use it, because in my previous video, I've used another method for determinant. In this video, I want to introduce another method for solving determinant, so which is called the Sarou's method. So we have this. So if I want to solve the determinant of this is what I'll just do. I'll rewrite this matrix. So I have 2, I have 1, and I have 0. I have minus 1, I have 0, and I have what? 1. I have 0, I have 1, and I have minus 2. Now, this is the original matrix. So what I'm going to do to use this method, I'm going to reproduce the first 2 columns at the, in front. I'll reproduce these first 2 columns here in front. So I'll have 2, 1, 0. I'll have minus 1, 0, and what? 1. So once I reproduce it, the next thing is to draw a diagonal of 3 elements. So I have this. This is a diagonal of 3 elements. I'm not taking this because this is not up to 3. So I'll take this. I'll take this, I'll take this, I'll take this, right? Yes. I'm going to multiply in this direction. So I have 2 times 0 is 0. 0 times this is 0, right? So I have 0. This times this times this is 0. So I also have 0. This times this times this is also 0. So I also have 0. I'll close it. Since I'm done multiplying this direction, I'll close it, introduce minus, then open my bracket and multiply the other way now. So I'll create another diagonal of 3 elements. So I have this, 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 and then I have this. So follow that, you'll see it. So minus 1 times 1 is minus 1. Then times minus 2 is plus 2. So I have plus 2. 2 times 1 is 2. 2 times 1 is 2. So I still have plus 2. Then finally 0 times 0 times 0 is 0. So I have plus 0. So if I add up this part is 0. I don't have to write it. So this is 2 plus 2 is 4. So times minus. So my answer is minus 2. So what it means is that A dot B cross C is actually going to give me what? Minus 2. And that is it. You can see that minus 2 is a scalar. It doesn't have I, nor does it have J, nor does it have K. It's a scalar. And that is why we call it scalar triple product. So we've gotten A dot B cross C, which is minus 2. Now let's try to see if we can find C dot A cross B. Let's see whether the result will still be minus 2. Once it's minus 2, it agrees with what I've told you. But when I'm solving this, I won't use this method of determinant. In case you didn't understand this, I'll use another method. So I have remember our previous answer is minus 2. So let's solve. So C dot A cross B is going to give us this matrix. I'm going to start this time around with C. And what are the coefficients for I in C? I part is 0. So I'll say 0. J part is 1. Then K is minus 2. Then I'll move to A. So A, I have 2. I have minus 1. And I have 0. Then I'll move to B. So for B, I have 1. I have 0. And I have 1. So this is what I have. I want to find the determinant. For you to find the determinant of this matrix, you should know that this is plus, minus, and what? Plus. So this is going to give me, I'll start with 0 outside, arrange my 2 by 2 matrix. So what I'm going to do is I'm going to close everything connected to 0 like this and like this. So if I close this and close this, you notice you can see minus 1, 0, 0, and 1. Then I'm done. I will go to minus 1 now. Minus 1. Create my 2 by 2 matrix. I'll close everything connected to this like this and like this. Then you see I have 2, 0, 1, 1. So I have 2, 0, I have 1, 1. Then I'll go to this. Plus, minus is still minus. So I have minus 2. I'll create my 2 by 2 matrix again. This plus times minus is minus 2. So this and this, I would have 2 minus 1, 2 minus 1, 1, and what? 0. So to get my answer, let's see, I have 0. This times this is what? Minus 1. I'll quickly put minus. Then I'll go, this times this is what? 0. I'll close. Then I have minus 1. I'll open my bracket. This times this is 2. I'll quickly put minus. This times this is 0. Then I go to this. This is minus 2. I'll open. This times this is 0. Quickly put my minus. This times this is what? Minus 1. When minus comes here, it becomes plus 1. So what is my answer going to be? Now watch. This is 0 outside. 0 multiply everything in this bracket is 0. So this one has gone. So I have 2 minus 0 is what? 2. Minus 1 times minus 2 is what? Minus 1 times 2 is minus 2, right? Yes. 0 plus 1 is what? 1. 1 times this is what? Minus 2. I think there's a mistake somewhere. I need to trace that mistake because this is C dot A cross B. There's a mistake somewhere. Let me try to quickly trace that mistake. So because I have C is 0, 1, minus 2. Then I have A is 2, minus 1, 0. I have B is 1, 0, and 1. So let me see where that mistake is coming from. So I have 0 into 0 into minus 1, 0, yes. And I have minus 1 into 2, 0, 1, 1. And I have minus 2 into 2 minus 1, 1, 0. So let's see. So I have 0 into this is minus 1 minus 0. This would go. I have minus 1. This is 2. This is 0. Then I have minus 2. This times this is 0. This times this is this. So except we made mistake in the first part of this, let me confirm.